Folks, just wanted to go through a locally installable demo of Redpanda's Iceberg integration. So this should run on any Kubernetes, but the cool thing is that we can also run it on local options such as Kind, Minikube or OrbStack, which means developers can use this as a development environment on their laptop without any additional services needed. So I'm using OrbStack here as my Kubernetes of choice, and up here on the left I have K9s showing me the running pods. Down left, I've got a terminal window, which I'll be using in a moment to go and run the setup script. And on the right, I've got the GitHub repo open showing the setup script content itself. And here you can see that the repo is at pnw-rp/iceberg demo. So let's kick off the script. It's a single script solution. And what this is doing is, first of all, installing MinIO. Now, MinIO is going to be our local S3 storage system. It's very simple to install. In this case, I'm just creating a namespace and running that sort of Helm install process. And once it's installed, we're then starting to configure it by obviously getting access to the credentials that it creates by default, and then going through and creating things like the bucket that we'll need. In this case, there's a bucket called Redpanda, and setting the access to that to be public as well. Once MinIO is up and running, we've then got to install Postgres. Again, a very simple namespace and Helm arrangement. But what we're also doing then is customizing that by running a initialization script. And that's going to be doing things like create the databases that we need, grants and roles, that are then necessary to be able to run Polaris, because this database, this Postgres, is going to be a backing database for Apache Polaris. With a Polaris, you can see a pattern. We're creating the namespace and going ahead and doing the Helm install. And in this case, once Polaris is up and running, we've got a little bit more config to do. We need to run a bootstrap job here to create the initial realm and user. And from that, we're then going to be getting access to a token and going through and creating the actual catalog that we're going to be using, along with the RBAC construct needed to give us access. So once Polaris is up, running and configured, we're now on to the process of installing Redpanda, which would obviously be very familiar. And the only real customizations that are going on here is we've added an additional listener of localhost so that we can effectively give port forward access to local devs for simplicity. And we've obviously pre-configured here the Iceberg REST catalog onto our Polaris, and we've pre-configured the tiered storage as well. The beauty of that means that when we've gone through this process, we have a full environment sort of pre-configured and ready to go without needing to do any additional work. After that, we set up a port forward and profile just so that we can start to get access in a very easy way just by using the RPK command line direct. Finally, the last part of this is we're going to be installing a Ubuntu pod and then running the DuckDB install script that they publish on their website. And DuckDB here is going to be used as our example for how to interact with Iceberg using SQL. So now that the setup script has run, we're going to go through and run one of the demos. So the way the demos are arranged is there are three of them. And the first is a key value exercise where you just, there's no schemas involved. The second uses an Avro schema and shows some fake syslog data. And the third shows a game telemetry. So in this case, what I'm going to be doing is I'm first going to be running the scripts. Now, the scripts are actually arranged into a numerical sequence so that you can see the steps in process and sort of run them that way. Now here, the first script that we're going to be doing is registering the schema. Now in this case, it's a JSON schema actually rather than Avro protobuf. So we go ahead and run that first script, and that will create the schema in our schema registry, and we've created a subject called telemetry value here. The second part of the demo here is we need to obviously create the topic. And this shows the simplicity of the Iceberg integration in action, really, because it's just an RPK topic create. And we're giving it a topic config here of Redpanda Iceberg mode of value schema latest, which is what we'd need to do for examples where we don't have that sort of prefix of a schema ID. So let's go ahead and run that now to create a topic. There we go, and the topic is created okay. Next, we're going to be either loading a pre-supplied telemetry file, which has all of the an example data set that we can use, or we can actually play the game directly here. So if I kick that off now, some of you will probably recognize this if you're as old as me. So this game is a version of an old game called Doom. This is called Chocolate Doom. And this particular port of Chocolate Doom has an additional ability to send telemetry from the game. So here we can configure the telemetry. Now this can write to Kafka, it can also write to MQTT, for example, or UDP. But in this case, we're going to be making sure that it's pointing to our Kafka broker of localhost on 9994, which matches, obviously, the Redpanda port forwards that we set up earlier by the setup script. So if we then save these parameters and launch, the game starts, and we can start to then see the classic Doom game running. Now, obviously, when this initial splash screen and sort of intro is just running automatically, it's still actually generating all the telemetry that is interesting. So this is sending JSON events to a telemetry topic, and if I go onto the Redpanda logs here, we'll eventually start to see Parquet files being written. Now, as these Parquet files are being written, here you can see the Doom demo is obviously demonstrating it's flushing all these events out. On a periodic basis, we then push those into the actual Iceberg structure itself. Now, we don't necessarily want to have an immediate upload of these files into Iceberg, because there's a balance to be had between how big the files are versus the actual sort of data latency. We also make sure you have a decent file size for Iceberg in order to have good performance on analytics. So here, still writing local files, and eventually we see these uploading into S3. So this is where we're starting to upload the manifest files now into Iceberg. So if I quit out of this game at this point, now that the game's been running, we should have some telemetry data to look at. So I should now be able to run the next stage in our demo, which is going to be give me an example breakdown count, in this case of the count SQL. So the query that we're going to be running here has a group by, and we're going to be grouping by type and just counting, just to get a feel for how many of these different event types there are. So if I run this last query, here we can see we're running the Iceberg integration through DuckDB. DuckDB is going to be installing the actual Iceberg utilities it needs first. And there you can see the query is executed, and we've got that breakdown of the different telemetry types that have come out. So I hope you enjoy this demo. Have a good day, and see you all soon.